Math 2, 11.4. Today we're talking about multiplying special cases. When you have special cases, you can multiply them the same way. What you have to be careful about is, see here how we have a plus b squared? That really means that you have two of those. It's a plus b times a plus b. Oftentimes people want to take this power, this exponent, and distribute it through the parenthesis. You cannot do that. Anytime you have a plus or a minus, which makes that a binomial or a trinomial, you have to use your distributive method or the box method in order to multiply. You can't take that 2 through the exponent, through the parentheses. Does that make sense? You will get the incorrect answer. Okay, so that's what that is talking about there. We are going to move on now onto page 663. So based on what I just told you on page 663, what am I going to do on A here? What does n minus 7 squared actually mean? Bless you.
N plus n.
N minus 7 times n minus 7. Okay, and since we're about half and half with some that like box, some that like distributive, you can do it any way that you want. I'm going to do distributive property this time. So I'm going to go n times n, which makes n squared. N times negative 7 is negative 7n. And then I'm taking negative 7 times n, which is negative 7n. And negative 7 times negative 7 is a positive 49. Here we have our like terms here, the negative 7n's. We add those together and we get, good, n squared minus 14n plus 49 is my final answer. Okay, do we have questions right now? Pretty much the same as what we've already done. So, on page 663, practice problem number 2. I'd like you to do that one on your own. And I will end up taking a volunteer to come up and do the problem with your method of choice. So I'll check your answer once you get it and take a volunteer. Practice problem number 2. Okay, so again, we're doing practice problem number 2. The answer is 16x squared minus 48x plus 36. And Stacy's going to come up and do this one for us. Okay, when you have these problems, I want you to do exactly what Stacy is doing right now and write it twice. I noticed that the ones that I checked that got it wrong didn't write it twice. Okay, now Stacy in her head is multiplying each of them through using the distributive property. She's not making her little lines. Is that okay to do?
Yes.
Yeah, it's fine. No, you don't have to. You're fine. You don't have to do things the way that I do them. Okay? It is okay to get answers different ways. That is perfect. Thank you, Stacy. Get a can if you want it. So yeah, if you don't need to draw the little lines, you don't have to, as long as you're not making mistakes. Okay? Do we have any questions on this problem? We're good? Okay. I want us to turn to page 664. Okay. This problem you are going to see on your test. Okay? You want to make sure you understand this. So, it says the figure at the right are squares. Find an expression for the area of the shaded region. Write your answer in standard form. Okay, so who thinks they have an idea as to what we should do here? First of all, how do we find area of a box? That's one thing we need to know how to do, or a square.
Base times height.
Base times height. So if we're looking at this big figure, how am I going to find the area of it? What am I going to do?
Base times height.
Which is what? What am I going to multiply?
X plus 4 times x plus 4.
Okay, so would you guys all agree that I need to multiply x times 4 times x times 4 in order to get the area of this box right here? Yes? Okay, can you guys multiply that for me? So when you multiply this, x times x, x squared, x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16, and we get x squared plus 8x plus 16. Does everybody agree with that? Okay. Now, that is the area of that whole big box, but what is the problem? This part is not shaded. Do you guys see that? So what would I need to do in order to take that piece out? Who thinks they know what you're going to do?
Area of this small box, and then subtract the
Exactly. If you didn't hear what Aaron just said, is he said you need to find the area of this box. So could we find the area of this box? Yeah, what would I do? So what am I going to multiply? Tell me specifically.
x minus 1 times x minus 1.
Good. X minus 1 times x minus 1. I'm going to multiply this one using the box method for those of you that do it that way. I'll try to go kind of back and forth doing it 2 different ways. And so when I multiply this one, x times x is x squared. Negative 1 times x is negative 1x. Negative 1 times x is negative 1x. And what's negative 1 times negative 1? It's a tough one. Positive 1. Okay? And so what do I end up getting here for this problem? Good. X squared minus 2x. Because there's my like terms. Negative 1 and negative 1 add to be negative 2 plus 1. Good. Now, so now that I know the area of this is, that's my area for my little box. And I know that the area of the big box is that, what will I do in order to just get the area of the shaded region? Subtract. Do you guys remember? So I'm going to take my big box, which is x squared plus 8x minus 16. And then we're going to subtract the little box. And this is what we did back in lesson 11.1. What you have to be careful about is what? Yes. What do I have to be careful about on this one? Changing your signs. When you're subtracting, you're changing all the signs, right? And so that's going to make this a minus, this one a plus, and then one a minus. So what happens with the x squareds? Cancel out, and then what do I get?
6x.
That's a positive now, right? So that's a 10x. And then 16 minus 1 is 15. So make sure you understand that you're changing all those terms and you're changing your signs and then combining like terms. And this would be units squared. They didn't say the units, but whatever this is, because we're taking the area, this is the area with units squared. Do we have questions there?
You always change the.
When you're subtracting, you have to change all the signs in front. Any other questions? Okay. Page 664. Or sorry, 665. So what do you notice about these two parentheses? Do you see on this one that one of them has A plus B and the other one is A minus B? Now, both of the front terms are the same and both of the end terms of the parentheses are the same. The only difference is one has a plus in the middle and one has a minus. What you find is that when you multiply this one out, the two like terms end up canceling out. You have a minus AB and a plus AB, and that cancels out and makes 0. So you just end up with A squared minus B squared, and we're going to get into this later. This is called a difference of two squares. So looking at this example here with x plus 2 and x minus 2, when this gets multiplied out, they go x times x is x squared, x times negative 2 is negative 2x. Hold on. Negative 2x. We have 2x times x is, 2 times x is 2x, and 2 times negative 2 is negative 4. I know. And so here we have our negative 2x and positive 2x, and that makes what? 0. You get x squared minus 4. Now, what they're telling you in this portion right here is that there is a shortcut. And the shortcut they're saying here is that if you notice that everything's the same and it's one is plus and one is minus, the shortcut is that you square the first term and minus, and then you square the second term. And you end up with x squared minus 4 instead of having to go through the whole process. If you don't remember this, could you always just multiply it out and they end up canceling out anyways? Yes, this is a shortcut. Sometimes shortcuts aren't great because we forget. Okay, so we're going to move on now to page 666. Sorry. So I'm going to give you just a little bit of time, and I want you to find the answer to A. If you need to do it the long way, if you feel comfortable, use the shortcut. No cell phones, please. You got the answer? Okay, what is it, Stephen? Good. X squared minus 81 is correct. Since these are the same, we can square the first term minus, and then we square the second term. Okay? If you went through and did the whole distributive property, you would get the same thing, and we end up with x squared minus 81. Are there any questions? Yes.
Couldn't you just use
The box method, yes. If you use the box method, I'll show you real quick here. So using the box method, we'd have x and 9 and x and negative 9. And so we're multiplying, we get x squared. X times 9 is 9x. Negative 9 times x is negative 9x. And negative 9 times 9 is negative 81. Just notice here that the terms here that are like cancel out. 9x minus 9x is 0. And so you get your x squared minus 81. I personally feel like going through the whole process is oftentimes safer to make sure you don't make any mistakes. All right, so let's go ahead and try B. B is just slightly different because it has m squared and then the 6 is in the front. I'm going to give everyone a minute, or not a minute, probably like 30 seconds. So you should be doing B right now on your own. Shortcut way or long way, either way. Okay, so the correct answer on this one is 36 minus m to the fourth. Okay, if you did it the shortcut way, do we notice how both of these are 6's and both of these are m squareds, but one has a plus, one has a minus? That means you will square 6 and a minus, and then you would square m squared. What do you do with powers to powers? No. No. Multiply them. And so you get 36 minus m to the fourth. If you use distributive or the box, you're going to get the same answer. Okay. Can you do number 7 quickly? Can you figure that one out? Okay, what is my answer for number 7? 100 minus y to the second is correct. How many of you got it? Good. Are we okay with the shortcut method? Okay, now turn to page 667. Can you use the shortcut method on number 11? Why not? Say that again. They are both positive. When is the only time you can do that shortcut? A positive and a negative, and everything else is the same. Okay? And so this one, when we multiply it out, we have c and a positive 3, c and a positive 3. C times c is c squared. C times 3 is, it's a tongue twister. C times 3 is 3c. 3 times c is, and 3 times 3 is 9. So my final answer is? Good. Plus 9. What am I going to do on number 12?
Make it 2 times.
Very good. Every single time you see this, you write that 2 times. G minus 4 times G minus 4. Okay, when you multiply this one out, G times G is G squared. G times negative 4, negative 4G. Negative 4 times G, negative 4G. Negative 4 times negative 4, positive 16. Shh, like terms we add together, we get G squared minus 8G plus 16. Can I use the shortcut method on number 13? So, be careful, because there is a 2r. We're squaring the 2r. Minus, we're squaring the 3. What is 2r squared? On this one, you're squaring the 2, which makes it a, and you're also squaring the r, which makes it minus, and then 3 squared is 9. Do we have questions? Okay, on page 668. A square is a side length of 2x plus 3. What is the area? What will I do to find the area of this square? Perfect. It's a square. So what we know that a square, all sides are the same or equal. So you're multiplying 2x plus 3 times 2x plus 3. Can I have a shortcut there? No, you can't. So we will multiply. I'm going to go ahead and use a box on this one. We have 2x and 3 and 2x and 3. When you multiply 2x times 2x, it is?
4x squared.
Good. 4x squared. 2x times 3?
6x.
Good. 3 times 2x? 6x. And 3 times 3? 9. We have our like terms there. And so we end up with?
4x squared plus 4x.
Perfect. Do we have any questions? Okay, last problem on page 668, number 18. In your groups, read this together and discuss it. How do you know whether it is convenient to use the rule for the product of sum and difference to mentally multiply two numbers? What they're talking about in sum and difference is like if you had x minus 2 and x plus 2. How do you know when it's okay to do that?
It's a plus and
It's a plus and minus.
And more than just a plus and minus, when everything's the same except for one has a plus and one has a minus. Okay, any questions on anything?